here, then calculate the power, then differentiate dP by dr. So it will be more troublesome. It's not that easy. Of course, we can do it, but time will not permit in exam. So what are alternatives method? So now can I replace this like a terminals here? So what this resistor will do, it will see some sort of the effective potential drop and everything. No? So I'll make the entire problem like this. This is RAB, this is VAB. And that particular resistance, I'll connect it here. When the power dissipated will be maximum, when capital R equal to RAB. So for this, what I should do now? What is the effective resistance as seen by AB? So what is AB? AB is this particular thing. How to get that resistance RAB now? Can we use grouping of cells concept? Earlier problem I did know grouping of cells idea. So what was the idea here now? What was the idea of problem previous one? Grouping of cells. You can't apply now. There's only one cell there. There's no much cell here. So what I suggest you is like how to calculate the effective resistance. Means I'll ask you to remove this resistance. The resistor R. Let's remove that. If I remove this, let's keep here. No, I'll continue the problem. So what I'm suggesting is like where all battery is there, replace the battery with internal resistance. It's a method. You can follow it. The EMF of the battery, this is E is there, no? You make it 0. When you make it 0, the internal resistance of cell will present as it is. So then this is 2 ohm. This is 3 ohm. This is 4 ohm. This is 2 ohm and this is B. and this is 1 ohm. So what is asking now? To get that resistance across EB. So what is the effective resistance as seen by the terminals A and B? That is what RAB. It's a method, it's a skill. It's verified in the lab. Then what happened? These are called like a Thevenin's theorem. Actually, you are not learning the theorem, but indirectly what happened? You are using the theorem. Like this, we have some around more than 250 different techniques are there, of which 10 are theorems are there. Like you are studying only 2 things, KCL, KVL. Like this, remaining 8 theorems are there to simplify the circuits. Okay, got this one? Then afterwards, there are 250 different skills are there, different methods, techniques they're called as. Different. So if you if you become electrical or electronic engineer, no, you must learn all this. How many skills you know how to use? Then what when you will become a very good circuit designer. So if you just go and check the television repair, mobile repair, any electrical, electronic gadgets or equipments, the person who does repair, no, he must know these skills. If he's having more skills, it'll be more better for him. He can find out the fault in the circuit very easily. So nobody will take pen, paper and work out here. Everything what pen, they take help of the skills. They'll identify in which branch current is flowing or not. So they identify the component. They'll check the ratings of that. So these are some 250 different techniques are there. It's approximate. Some books they say 300, 250. That one if you refer different books, no higher books, no in engineering book. I'm electronic engineer, no, so I do come across all the different measuring techniques. That one. Any complicated circuit we can manage. For everything, there's a method is there without putting much effort. These are called techniques here. So we will see next week when we discuss some numericals. I'll introduce some around 10 to 15. You can see different methods. And then the theorems already you've seen KCL, KVL, and the maximum power transfer theorem. Okay, next one more, the nodal analysis method, I'll tell you. Like that, many theorems are there. Okay, let's come for that. Okay, this is about the thing now. So what is effective resistance as seen by AB? So look at this, how to calculate this resistance across AB now. How to calculate this resistance AB. We have to find out effective resistance between the terminals AB. Can we, are these two on its same potential? So are 2 ohm and 3 ohm. So let me redraw the circuit. We'll see, is it possible or not? We'll check it now. No, I'll put it here now. So this is 3 ohm. This is 3 ohm. This is 2 ohm. 2 ohm and this is 4 ohm. Not shape. I'll bring some suitable shape. This is point B. This is point A. This is 3 ohm. This is 2 ohm. This is 2 ohm. And this is 4 ohm. And that particular resistance. No. Let me slide down a little bit. And the resistance 1 ohm is here. We have to calculate this particular resistance. So at least a little bit the diagram. Now effective resistance as seen by these terminals. How to calculate this? So we'll do one thing. So it is, so for further I'll simplify the thing. So this is 2 ohm. Can be asked, so that the probability of asking any of these type of question. 4 ohm, 2 ohm, this is 2 ohm, this 3 ohm, and this is A and this is B, no? And the resistance 1 ohm is here. This is what happens. We have to calculate the effective resistance across AB. So let's assume that some cell we are connecting it, then we have to calculate it. So this will further, and I'm using one more method. So there's everything will be like, if you read out the circuit, no? This is 2 ohm. This is A. This is 3 ohm. This is 1 ohm. This is 4 ohm. Yeah, now this is there. I'll ask you to bring one a cell, so some voltage. Huh? So this is imagine to get the answer. So how can you assume you remove cell again? You're bringing just to get the, so what happened, the particular effective resistance RAB, that one. So that I'm bringing. So here I'll bring some V naught. This is to make problem simple. Let me bring 2 volt. So a current I will flow. So what this cell, it will see the effective resistance, no? RAB. It will see the total. It will see the, I'll calculate the current. So there's everything. It will see like this. A and this is B. RAB. And I'll find out the current through it. I know V naught equal to volt and I'll get a current I. If I can calculate current I, so what is RAB is equal to? RAB should be equal to V naught by I. So V naught I know. 2 volt. If I can calculate this current in through the cell, I'll substitute, I'll get RAB. Then I'll get the required answer. So something is troubling you, this one. So how to calculate this particular thing? So how many loops are there? So here current I will come. So here I1, I minus I1, or this will be I1 plus I2. I'll write it. Yeah, okay, fine. I2. Let this be I3. I1 minus I3. This will be I2 plus I3. The total will be again I. So what is I is equal to? I1 plus I2. Now, can we find out I1 and I2? I1 and I2, I3. Loop equations. So the polarities, current entering, leaving, positive, negative, positive, negative. This will be. Now write the loop equation. Plus 20, plus 2 volt, minus 2 I1, minus 4 I1 minus I3 equal to 0. So this will be 2 minus 6 I1 plus 4 I3 is 0. Then, so one more loop, I'll write it. 2 minus 3 I2. This is the path. The first one I went like this. Plus 2 minus 2 I1 minus 4 I1 minus I3 equal to 0. Next again, I'll go for the path. Plus 2 volt minus 3 I2 minus 2 I2 plus I3 equal to 0. Equal to 0 it is. So this will be 2 minus 5 I2 minus 2 I3 equal to 0. Okay, now one more equation is there. So to take any one loop, so this will be minus 2 I1 minus I3 plus 3 I2 equal to 0. This is equation 3. Solving 1, 2, 3, we'll get the expression for I1, I2. And I'll get I. That I'll substitute, I'll get RAB. Then what was the value of R? The R was equal to RAB, no? This was the required answer. Now there's a one, you can say method. From somewhere the problem was something what it was, maximum power. From there what happened, we shifted to some other method. These are the various things. Or else what you should do, what is other method? So divide the current I will flow I1, I2, I3, then get expression for current through the resistance, this in terms of R, then calculate the power, then differentiate dP by dr and equate to 0. Anyway, either one, it will be more difficult. That will be still more lengthier. Instead, I shown alternative. So here afterwards, if you want to find out effective resistance across any 2 points in a circuit, what is the method? Replace the cells with internal resistance. Here, luckily what happened? Here, what is the bad luck? The bad luck is that the cell was having internal resistance 1 ohm. That's why. So what happened? The problem has become lengthier. Replace all the cells with internal resistance. Then you get pure resistive circuit. Then find out the effective resistance across the terminal CB. And that will be the effective resistance as seen by the resistance capital R. This I'm going to continue for almost 3-4 chapters, this idea. Hereafter, how to find out effective resistance of circuit. This is one more method. Where all cells are there, replace with short circuit. Then replace with internal resistance. So when potential becomes 0, what you should do? Short circuit. So in place of cell, I put short circuit. That internal resistance you have to add up. If the cell is ideal, then what you should do that one? Then this will become 0 ohm. Then a wire will come. Then these two will be at same potential. These two add. Then redraw this circuit. Then we have to work out